Body cavities and serous membranes. The body maintains its internal organization by means of membranes, sheaths, or other structures that separate compartments. The dorsal or posterior cavity and the ventral or anterior cavity are the largest body compartments. These cavities contain and protect delicate internal organs, and the ventral cavity allows for significant changes in the size and shape of the organs as they perform their functions. The lungs, heart, stomach, and intestines can expand and contract without distorting other tissues or disrupting the activities of nearby organs. Subdivisions of the posterior or dorsal and anterior or ventral cavities are each subdivided into smaller cavities. In the posterior cavity, the cranial cavity houses the brain, and the spinal cavity or vertebral cavity encloses the spinal cord. Just as the brain and spinal cord make up a continuous, uninterrupted structure, the cranial and spinal cavities that house them are also continuous. The brain and spinal cord are protected by the bones of the skull and the vertebral column, and by cerebrospinal fluid. Cerebrospinal fluid is a colorless fluid produced by the brain, which cushions the brain and spinal cord within the posterior cavity. The anterior cavity has two main subdivisions, the thoracic cavity and the abdominal pelvic cavity. The thoracic cavity is the more superior subdivision of the anterior cavity, and it is enclosed by the rib cage. The thoracic cavity contains the lungs and the heart, which are located in the mediastinum. The diaphragm forms the floor of the thoracic cavity and separates it from the more inferior abdominal pelvic cavity. The abdominal pelvic cavity is the largest cavity in the body. Although no membrane physically divides the abdominal pelvic cavity, it can be useful to distinguish between the abdominal cavity, which houses the digestive organs, and the pelvic cavity, which houses the organs of reproduction. To promote clear communication, healthcare providers typically divide up the abdominal cavity into either 9 regions or 4 quadrants. The more detailed regional approach subdivides the cavity with one horizontal line immediately inferior to the ribs, and one immediately superior to the pelvis. Also, 2 vertical lines are drawn as if dropped from the midpoint of each clavicle or collarbone. There are 9 resulting regions. The simpler quadrants approach, which is more commonly used in medicine, subdivides the cavity with one horizontal and one vertical line that intersects at the patient's umbilicus or belly button. A serous membrane, also known as the serosa, is one of the thin membranes that covers the walls and organs in the thoracic and abdominal pelvic cavities. The parietal layers of membranes line the walls of the body cavity. The visceral layer of the membrane covers the organs. This is called the viscera. Between the parietal and the visceral layers is a very thin, fluid-filled serosal space or cavity. There are 3 serous cavities, each having their own associated membranes. The pleura is the serous membrane that encloses the pleural cavity. The pleural cavity surrounds the lungs. The pericardium is the serous membrane that encloses the pericardial cavity, and the pericardial cavity surrounds the heart. The peritoneum is the serous membrane that encloses the peritoneal cavity. The peritoneal cavity surrounds several organs in the abdominal pelvic cavity. The serous membranes form fluid-filled sacs or cavities that are meant to cushion and reduce friction on the internal organs. Both parietal and visceral serosa secrete thin, slippery serous fluid located within the serous cavities. The pleural cavity reduces friction between the lungs and the body wall. Likewise, the pericardial cavity reduces friction between the heart and the wall of the pericardium. The peritoneal cavity reduces friction between the abdominal and pelvic organs and the body wall. Therefore, serous membranes provide additional protection to the viscera that they enclose by reducing friction that could lead to inflammation of the organs. Thank you for watching.